Since the beginning of this channel, I never properly talked about concurrency, and we're not really going to start now. I'm still going to explain just like the things that are necessary, and I really hope that you don't hear this drilling. All right. So an integer increment, for example, it feels like one operation on the JVM, but down there, down at the CPU level, it's actually multiple operations, right? So you read something from the register, the current state, then you change it, this is the second operation, then you write it back, right? So one tiny increment of an integer is actually three operations. So this operation is said not to be atomic. Now, we're not dealing with integers anymore. If you look into the statement, we actually have a vector, right? So this is our state. And so we're going to use a thing called atomic reference, which the Java people came up with at some point. And it's essentially a container which exposes methods that would allow us to access the state within and update it atomically. The way atomic references work is they expose a method called compare and set. Okay, and the way it works is that before you call it, you read so you create a loop, and you first read the state that is inside, okay? And then you call compare and set, and you give it two things. You give it the state that you have just seen and the change, the desired state, right? So your change, okay? And then you call this method, and if the state that you have seen just like a nanosecond ago, if it didn't change, then this method will return true, and it will update the state inside. But if some other thread or something else change it in this split nanosecond, it will return false, and so you will just keep repeating this loop until forever. The implementations, the low-level implementation doesn't use any locks, so it's way more efficient than locks. However, it is still, it still will it will still have to coordinate some stuff, so this is not the most performant thing in the world. However, as of right now on the JVM, this is pretty much the best thing you have if you need to deal with concurrent state, as we're doing right now. With a real database, this is what the database is going to do for you. If it happens to be written, in a language that runs on the JVM, it's going to do this for you. Okay, but usually they're written in C, and then they have like semaphores and all this other stuff that we have in Java as well, but they use locks. Not the point. So what we're going to do now is we're going to go and implement it, and we're going to implement a functional wrapper called ref around an atomic reference. It's going to live in Cats effect, and once we're going to throw everything out and throw our implementation of Cats and Cats effect out, replace it with the real one, everything is still going to compile because we're going to make sure that we're going to implement exactly the same DSL as in the real one. So let's go and see. So we have Cats effect, and there's a package called effect. I'm going to go and we're going to say we're going to create a new file, and it's going to be under concurrent.Ref.Scala. All right. So the package is going to be Cats effect concurrent. Okay, and it's going to look like this. It's just going to be a ref of f and a, right? So we need the f because tagless final, and we need the a because it's going to be the state. Okay, and the only method for now it's going to have is going to be called modify, right? It's going to get a function that goes from a to a, right? So it's going to go, so you need to like read the value out, see like the current a, and you're going to modify the a somehow. And because it goes from a to a, we're going to call it AA. Okay, it's going to go from a to a, and it's going to produce an f of a. It's sort of similar to a functor somehow, right? All right, so we're going to go and do object ref. Let's create more space, and we're going to do the same dance as before. We're going to say DSL. We're going to rename it in just a couple of seconds to match the implementation in the real Cats effect. Okay, so we're going to pass it like the initial state, right? So in our case, it's going to be like this vector empty of to do, okay? And it's going to produce a ref of f and a, okay? And it's going to do a new ref of f and a, and it's going to do this. And let's talk to metals real quick, like this. And there we go. And by the way, we don't need to do like effect.sync because I'm structuring my packages like this, and therefore we have access to everything that is inside of effect. Now, since we're mimicking Cats effect, this method is actually going to be called off, right? So we're going to be able to say ref off, empty vector. Okay, cool. So the implementation for modify is actually super simple. It's actually exactly like what I said in the beginning. Okay, so we're going to have a helper function, which is going to be called set or die trying, and it's going to produce an a. Okay, it's going to it's going to side effect, right? It's going to go and try to modify some stuff, and then once it returns, then we'll simply go and we'll delay that. Okay, right? And now it's going to be referentially transparent. Okay, and the way we're going to implement it is first we're going to have a private state, right? It doesn't actually need to be private because we're only exposing this trade through this. Okay, so I'm only making it private so that it's just for readability. Okay, so we're going to do atomic reference of A equals this. Let's have an import like this. There we go. Okay, and the way you create it is by basically saying new atomic reference of A. Okay, like this. Nice and easy. Cool. So the implementation is actually super simple, and as I already said, we're going to have a loop. So this is going to be a Scala annotation dot tailrec function. Okay, so we're going to go over here, and first we're going to read out the current state. Current state is going to be state.get. Okay, so this atomic reference, it has a bunch of methods, and get is one of them. So this is how you get the current state out. Okay, then we're going to have desired state. Desired state is going to be AA of current state, right? So we're basically just applying the function. Okay, cool. And now we're going to say if, and we're going to call this compare and set function, which returns a boolean if everything succeeds. And we're going to say, okay, this is the state that we have just seen, current state, and this is what we want to have, desired state. Okay, and so if it returns true, so if everything went well, we're just going to return the desired state. Okay, we just want to return the A. Otherwise, we're just going to set or die trying, like this. Okay, and this is already the entire implementation, if I spell it correctly, desired state. That's it. All right, very simple. Now in Cats effect, the signature for modify looks a little bit different because they essentially built a map into it. Okay, so we're going to have an extra b over here, and therefore we're going to produce an f of b, and therefore this function is going to go from a to ab. Okay, so this is just going to be a tuple. Okay, so it's essentially like, for example, like we can update this vector and we can map this vector to something else, like sort of like in one operation. Okay, so let's go grab this, put it over here like this. All that it means is that this function AAB is going to return a tuple, right? It's gonna return the desired state, and it's going to return the result. Okay, and now over here we're going to return the result. Okay, and also this function is now going to return a b because we need to return an f of b. Okay, so everything is kind of still the same, but we're we can sort of like sneak in a tiny morphism in there. Okay, so we can actually morph this a when it comes out straight into a b. Okay, now we also have a bunch of helper methods. So we're gonna have a method called update like this. It's gonna take in the f, a to a, and it's going to produce an f of unit. Okay, we're gonna have update and get. It's gonna take the AA and produce an f of a. So this is pretty much the one that we had before, right? And all of them are going to be implemented in terms of modify. Okay, and we're also gonna expose get, which is f of a, and set a f of unit. One of the things that you need to know about atomic reference is that not every function on it is actually well, not stack safe, but not every function on it is actually atomic. So if I do this, and if I go over here, if we go do state, let's do set get and set, for example. Okay, it says atomically sets to the given value. Okay, but if we just do set, it's going to say sets to the given value, so I guess it's not atomic. All right, just one of the peculiar things to know about, because if you're dealing with atomic reference, it doesn't mean that you always need, like in every operation, you need it to be atomic. So for example, when we're going to delete all the to-dos, we actually don't need to care about what is currently in there, right? It doesn't matter if some thread like modifies something in between, right? We just want to remove everything, so we're just going to set a vector empty. Okay, cool. So let's go over here and let's go and let metals generate them for us like this. Implement all members. All right, like this. The implementation is going to be very straightforward. So this one is just going to delay state.get. This one is just going to delay state.set a. Okay, how did this happen? Delay, and this one is also wrong. Delay like this. All right. So this is going to be the update. So the update is just going to call update and get with an AA, and then whatever comes back is just going to nullify it by saying void. Okay, so this function should be called AA, and therefore it's going to be called AA over here, like this. All right, it doesn't have a void because we need the syntax. So import cats implicits. Oh, let's actually do syntax. Cat syntax all like this. Oh yeah, we don't have this because we don't have the real cats. Okay, so let's just do cats implicits. All right, kind of forgot real quick, and let's have Java first, like this. All right, so we have update, and now we just need to do update and get, which is just going to be implemented in terms of modify. All right, so let's actually put this var, let's take this var out and put it over here, like this, like this. Okay, so update calls update and get is going to call modify. Okay, so all it's going to do is going to call modify, and what it's going to do now, it's going to change this function, right? It's basically going to adapt this function, right? So it's going to say, okay, so let's say that that we're starting with an A, okay, then we're going to have the desired state. It's going to be AA of A, okay, and we're going to have the result, and the result is also going to be the desired state, right? So A and B are in this case exactly the same thing, and so we're just going to return desired state and result. Okay, so in this case, like modify is gonna like return exactly the same thing. It's gonna return an identity. Okay, and this is it. This is pretty much the entire ref. Like the real ref, it's gonna have like way more, way more functions. And if you remember from the beginning of this video, or if I cut them out into two then from the previous video, I said that there is also like this thing that we need to talk about, right? So there's still like this not ideal thing that we're going to have to talk about in the end of this video, but basically it's going to be about we're going to have a conversation about the creation of mutable state, and creation of mutable state needs to be delayed as well, right? So for example, this thing, it's mutating this variable technically, right? Because like, on the JVM, it sort of starts with a null, you don't see this, but like every var, it starts with a null. But then, the initialization comes along and initializes this variable, right? So we will talk about this a bit later in the video. So all we need to do now is we need to actually go and use it. So we're going to go back to our statement, and we're going to say that this state is going to be an atomic graph. Okay, so we're just going to replace this. We're going to say that it's going to be a val state, and the state is not going to be effect concurrent ref of f and vector of to do existing. Okay, existing, and it's going to be effect.concurrent.Ref of vector.empty. Okay, let's call it state 2 for now. State 2. So we see that it compiles, and it does. All right, cool. So now we're going to throw this one out, and we're going to use state over here in all of the places. Okay, so we're going to call this one state. Going to remove this like this, and we're going to go and try to fix everything. Okay, so now we don't need to delay anything. In fact, in just a couple of minutes, we're going to get rid of sync finally. So instead of doing f.delay state, let's actually do it over here, right? Instead of this, we're just going to say state.get. Okay, right? So the delaying is already happening there. Okay, so next ID is going to be select all, map, and the same thing as over here, right? So because remember, like the size is basically the size of the, I'm sorry, the ID is basically the size of the vector. Okay, so we're just gonna do this. Okay, so this is the next ID. Okay, insert one. So basically, like all the places where we do delay, we're gonna access the state instead. Okay, so instead of this, okay, we're just gonna say state.modify. Okay, so this is gonna be the current state. Okay, and we're gonna do same thing as below, but notice that we're not going to have the equal sign, right? Because we're not dealing with the mutation, right? So this modify is going to do the mutation for us. Okay, created. Okay, and because like modify, as a reminder, has like this this notion of a map built in, we actually don't need to do this like as created, right? We can just construct this tuple over here, and we can say, whenever you update it, just return the created thing. Okay, so we can do it like this. Same thing for update 1. No need to delay anything. We can just go and we can just do state.modify. State.modify. Okay, this is going to be the state, right? So we have the access to the state like this. Like this. Okay, and now we're just going to do, let's grab this one. This one. Okay, so this is going to be as dot filter not. All of this is going to stay exactly the same, and we're going to just wrap it. And again, we can just return the to do, right? So the second element of the tuple is going to do like this part for us. Okay, we don't need it actually, right? So we can still like instead of this, we can call. Let me show you a different implementation real quick. So we can do update and get, I believe this is how we call it, right? So one of our helpers, right? So this one, right? So we can just do update and get, and therefore we can remove this. Okay, and then in the end we're going to do the same as before as to do. Okay, so this implementation is also valid. Okay, but you know, if modify already has this thing built in for us, then why not use it? Okay, so let's go like this. All right, same thing over here, you know, state dot. In this case, we're actually going to use update, right? Because we're returning an F of unit. And if you remember, update, it's just going to, you know, call update and get and throw everything out. Okay, so we're just going to do update, and this is going to be the state. And we're going to do that thing like this. Oops, Control V. And does it look the same? Yeah, it does look the same. All right, like this. Okay. Maybe it's actually going to fit into one line in this case. Let's see. Yeah, it fits into one line. How cute. All right. So yeah, delete all, and then this one we're just going to set. Okay. So we're just going to set. We don't care about atomicity. We're just going to set the whole thing to empty. All right. There we go. And as of right now, we should be able to, you know, go see it in action. So we're going to run, and we're going to create, we're going to say, you know, buy milk 227 4 11 43 show all everything still works, right? So it's all good. Right, quit and go back to compilation, and the next thing that we're going to do is we're finally going to get rid of sync. And the way we're going to do it is basically by saying that let's actually not have this ref. Let's actually inject this ref instead, and you know, ref is going to deal with the sync, right? Because the only reason that we need sync is because ref needs sync. Okay, but if we're doing composition, then we're actually not gonna need it. So first of all, let's actually import it. Cats effect concurrent.Ref. Okay, so now we can do this. Okay, and we're just gonna say that we need it as a parameter, right? So we're just gonna say state. Well, basically this whole thing. Just please give it to us. Okay. Like this. Now, the code somewhere else is not going to compile now, but everything over here compiles. In fact, we actually don't even need a sync anymore. Let's see what we actually need. Let's just remove it. Okay, so we need map, so we need a functor at least. Okay, over here, so we need at least a functor like this. What else do we need? We're using flat map. Okay, so we need flat map. Flat map. You can sort of deal with the context bound as was imports. And look, the whole thing compiles. Okay, so we just need functor and we need flat map. Okay, and now we can actually go to the in-memory gateway, right? And it's gonna say, hey, I need a ref. And so we're just gonna, you know, pass it along. We're just gonna do a state over here and go back to the statement and basically copy, where is it? Copy this, right? So you're basically going to say, hey, I don't want to deal with this either, you know, just like give it to me. Okay, so like this, just give it to me. And therefore we also need to do to have this import. It's very long. Like this. Cats.effect.Ref, and that should be enough. And therefore we probably don't need the sync over here either, right? Because we're not delaying anything. Okay, so let's see what we need. Okay, so we need a functor. We need a functor. What else do we need? Flat map. All right. Flat map. What else? And applicative. Oh, okay. So functor, flat map, and applicative. It's a monad. Okay, so we can just say monad. All right. Oh, look. This is all we need. We just need a monad. Okay. So now we need to go into the dependency graph. Dependency graph, which is over here, and here we're going to have to make exactly the same decision. You know, do we want to construct the ref over here, or do we want to, you know, to move the problem out again to the program, to the program which is over here, right? So we can construct it here and inject it, or we can construct it over here. This is actually sorry, no, it didn't stay open. No, not this one. Dependency graph. Okay, so this is actually one of those tricky things, because like if you have a database, right, then the connection pool would just be like passed in over here. And with this ref, it can kind of like, it's atomic, right? The whole point of it is that it can be shared through the entire application. So technically, we should be able to go into the program, which is closed again. And we technically should be able to create it over here and say that it's a vector empty over here, and then just give it to like all the use cases that we need. Like as of right now, we have only the CRUD use case, okay? But for now, you know, I'm just gonna go and build it, you know, build it in over here, okay? So all I'm going to do is I'm going to go over here, and I'm gonna say that this is gonna be a ref of vector dot empty, like this. That's all we need. We just need the import gets effect concurrent.Ref, okay, like this, nice and easy. Okay, so now we can go and we can do run, and we're just gonna go and say show all. It still starts with an empty thing. Create bimilk 227 74 11 48 show all. There we go. Everything still works, nice and easy. Scroll down like this so that we have more space. All right, so now let's finally talk about this thing that I was talking about all the time. You know, that we need to delay the creation of the mutable state. So if you go to a program, remember this print line. Okay, so let me actually demonstrate this to you. So if we go to something like ref, okay, and we're gonna go and over here, let's just have a print line state. Not a big deal, right? Let's go and run it. Okay, and now we're going to see it over here, and as the message says, any output before this line is a bug. Now, as of right now, it's not a big deal. It's just a print line. Who cares? But if this was like a real database, you would not want to access a database when you're just constructing a program, right? And therefore, pretty much like as a rule of thumb, everywhere where we use sync, we're going to wrap the entire creation of this thing into a delay. Okay, so we're going to do this right now, and it's super easy to do. It's super easy to do, but if this is like the first thing that you see, then it's kind of scary. Okay, so ref.off is not going to produce a ref, it's going to produce an f of ref, like this. Okay, and therefore all we need to do is we need to go and wrap this entire thing into a delay. Okay, curly brace over here, curly brace over here. Right, that's it. So the entire code base isn't compiled now, but at least over here it compiles. Okay, some people don't like this, and you know, you can do whatever you want. So some people go and they basically cut this out and go over here, and instead of using an anonymous class, you would say something like class I don't know, implementation, whatever, implementation. Okay, and it's going to have a private constructor, and it's going to extend the ref. Okay, and so over here you're just delaying, you know, the new implementation for it's still going to need like all of this stuff. Oh, and in this case the constructor is actually going to need the a like this. Okay, so like this. Okay, did I spell it wrong? Like this. New implementation. Constructor implementer cannot be accessed in object ref. Really? Let's do it like this. Okay, whatever. Right. So if you find this nicer, then you know, feel free to go do it. I'm actually going to revert this. Okay, so this is like, I don't know, kind of easier for me to read. I'm just delaying the whole thing. You kind of lose a little bit of space over here, like all of this empty space. Okay, so now we need to basically, before we go and improve everything, we need to go to like all the other places that use sync directly. Note that the dependency graph itself, it's going to say, hey, I also want sync. But at this point, everything else is already going to be delayed. So we're not going to need to delay anything here. Okay, so let's go to the console. It needs the sync. Okay, so we're going to do exactly the same thing. So it's going to return an f. Okay, and therefore we're going to do f.delay, curly brace over here, curly brace over here, right? Very mechanical. Let's go random, do the same thing. It's going to return an f. F. Okay, left that delay like this and like that. All right. And now that we have all of them together, we can actually go back to the dependency graph over here. And now like this call is going to produce an F of the state. Okay, so we're just gonna cut it out. Okay, we're just gonna go over here and we're simply gonna map it, right? And inside of it is going to be the state that we need. And now we can put it over here. But this also means that the entire thing is now producing an F of the controller. Okay, like this. We might need to help out with some types. So we might need to do that existing over here, existing, like this. What do you want? Map is not a member of. Okay, so we need cats implicits, like this. Let's see if we actually need this type. We probably do. Yeah, we need this type. Okay, like this. Cool. So now all we need to do is we need to go to the program. And instead of doing this, we pretty much need to flat map a bunch of things. So first of all, we're going to do this. Okay, so now we're going to wrap this into a full comprehension, right? So this thing is going to be over here. Okay, so now over here we're going to do console.dsl. Over here we're going to have random.dsl. Okay, and therefore we're going to put the console over here, random over here. And what else does it want? It wants nothing. Okay, so now because this is a full comprehension, this is how we rip out the console, this is how we rip out the random, and this is how we rip out the controller. Okay, and now we're going to yield the controller, right? And because of this, it's not going to be a controller, this is going to be an F of a controller, Okay, and because of this is we need to go and use another flat map over here. Like this. Now I know it's kind of a lot because we did it like the whole thing like in in the same go, so to say. Okay, it's 3 errors. Hold on. Value flat map is not a member of. Yes, it is. Like this. All right. Cool. And as of for now, we can actually go and well, let's run it. Let's run it real quick. Let's go and run it real quick. And as you can see, so right now, oh, I actually removed this print line. Print line state. Okay. So we're gonna run it. Okay. And now we're seeing this vector after this empty line, right? So after, right? So we constructed the entire program, right? So this print line already happened, right? So this was the construction. After that, we called run in the main. Where is it? After that we called unsafe run sync, and only then, only when we were running, only then we were seeing this print line. Okay. In fact, in the upcoming videos where we're gonna use a real database, we will start the application even if the database is not running, right? Only once we're gonna start and say, show all or something, only then it's gonna explode, right? Because of these things, because of this this whole delaying things. Okay. Right. So let's go back to the program and let's inline this a little bit. So let's go do this. Okay. Because this is just another another flat map, right? So we can just go and move it over here, right? We can just do, okay, program equals, well, this is basically equals, right? It is basically controller dot program, right? And now we can return the program, okay? So we don't need this. And now this entire thing is an F of unit, okay? And which is this. Okay, so the entire CRUD controller now becomes the program, like this. Okay, in fact, let's actually throw out this print line, right, and throw out this thing, and throw out that thing. Okay, so this is now the entire program. And as a reminder, this one is unit. Okay, so we can just do an underscore here and do that. Okay, so this is how you would typically assemble the entire application, right? So you're gonna have this big for comprehension. You're gonna have all of your use cases over here. They're all gonna have access, they all gonna receive the access to the connection pool, as we will see in the upcoming videos. So the connection pool will be initiated of initialized over here. They will all receive it and they will all work with it. Okay, right. Let's run it again real quick. And let's also remove that thing from the vector. We don't need it. Okay, so quit, run again, show all, noted is found, create buy milk 227.4, 1158. All right, show all. It's all working exactly the same as before. Nice. So we're pretty much done with this video. We're just going to replace everything that we have with, with the real cats and stuff. Before we do that, there's an awesome compiler plugin. I don't have much experience with it, but if you're doing, like completely functional programming, I advise you to use it. So because we're finally using for comprehensions in the program over here, this plugin is going to rewrite the for comprehensions a little bit more efficiently. Okay, so if you go to the dependencies, and we're going to go down to here, I'm just going to paste it in. Okay, so it's going to become like by beta monadic 4, right? So this is how it's called. Not now. Let's go to the build and let's go down to the common settings, and we're going to use it over here. So it's going to become oleg pi, and it's going to be called better monadic 4. Now, as of right now, we shouldn't see any difference, right? Just that this plugin is now there, the full comprehension is now rewritten a little bit differently, but it should behave exactly the same, right? So run, enter, enter, enter. Well, we don't see that I'm pressing enter, 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 enter. Show all. It's all good. Okay, let's switch back to compiling. Let's finally bring in some real cats. Okay, we're gonna go to dependencies. It's gonna be org type level. Okay, let me paste this in so that we're not sitting here all day. Cats core, cats effect. Okay, so now we can go to the build, and basically, so what we're gonna do is we're gonna leave them over here as of right now. I'm actually gonna throw them out after this video, but for now we're gonna leave them over here. It's just that we're not gonna depend on them. Okay, so over here we're seeing depends on domain, depends on cats core. So this one is going to be thrown out. So these ones are tests. So let me just duplicate this line, close it over here, and do this over here. So we're going to say org type level cats core. Okay, like this. Let's see what else. We have delivery. It has a dependency on cats effect. So let's just do this. Let's copy that. Okay, bring this in over here. Comma over here like this. This is going to be the closing one. So this is going to be cats effect. Let's save it real quick. Nope, not now. What else? Okay, the same deal over here, the persistence. So we can pretty much have this. So both delivery and persistence, they both need cats effect. And yeah, I actually believe this is it. Okay, so as you can see, everything still compiles exactly the same. Because we have this setting over here. Everything just reloaded, and everything compiles exactly the same. It runs exactly the same, But as of right now, if we go to something like program, well, actually, we need to make Bloop happy. Import build metals and Bloop. I wanted to jump into sync, and then you would see that this is like the real deal now, right? So right now I can just keep pressing enter. It's never going to explode because the IO, the sync, the IO in Cats effect is properly trampolined, the same as in monix and the same as in Zio. So you will never run into any issues with this, right? So this is just a theoretical concern because you're never going to be the one who is actually going to implement IO yourself. All right. Cool. Let's quit that, and let's actually go and also add not only Cats effect but also add Zio and monix. So we're going to go into the dependencies again. Let's actually keep compiling. So we're going to go to the dependencies. Okay. So Zio is one of the lucky ones who bought the dev domain. So it's going to be ABCD. It's going to be over here. Right. So Zio doesn't really promote the tagless final style. So usually when you're doing like a full-blown Zio application, you would not have the tagless final style. However, it is compatible. It is compatible with the tagless final style. It is compatible with, so it has an extra module, which is an interop with Cats, the Cats ecosystem, right? So there is an implementation of the Cats effect type classes in Zio. Okay, and we also need monix, which is in IO. ABCD. Okay, so it's going to be over here, right? So monix has multiple modules. We only need the monix eval. No, please not now. Okay, so now we're going to go to main. To the build. In the main, we're going to say that we're going to have also more dependencies over here, right? So we're going to have this, we're going to have that, and we're going to say that we also want def zio zio, and we want def zio zio interrupt cats like this. All right, and we also want io monix eval like this. Okay, we don't need to specify that we need cats effect because these guys already depend on cats effect. In fact, this is one of the complaints about cats effect, that it also has the implementation for, so that it doesn't only have the type classes for effect types like sync, but it also comes in with its own IO thing. Okay, the only tiny thing that we need to do is we're importing dependencies at the top, and IO collides with something. So we need to go over here and we say dependency IO, okay? And now it's gonna be happy, okay? Like this. And as you can see, it is happy. Let's go and import the build. And while it does that, let's actually go to the main. Let me close the others. Now, we're going to write a fancy main that is going to randomly pick the effect type, and it's going to run with it. If you're creating a real application, you would never do this. And so you're going to use a helper that comes with, I'm pretty sure that each individual library comes with its own helper for app. For example, for Cats effect, let me comment this out. We're going to do object main extends IO app like this, and we're just going to do this, and we're just going to do import Cats effect like this. We're going to go over here. I'm going to say please implement all the members. There's only run, okay? And so the run is going to do program.dsl for IO, right? Because we're already importing Cats effect, and we don't need to do unsafe or unsync. All we need to do is we need to do as execode.success. Okay, so this helper will basically, you just basically give it IO and it's going to run it for you. Notice that we're not importing cats implicits, and this as thing still compiles. If we jump into it, you're actually going to see that Bloop did not realize that we're not using this one anymore. Let me actually double check this. All right, so depends on. That's fine. That's fine. That's fine. That's fine. That's fine. All of them are fine. I'm not sure why Bloop got confused and it jumped in there. It should have jumped into like the real IO, the Cats effect IO. That's interesting. This should be the real IO though. Okay. In any case, let's run it real quick, and you should see that it runs exactly the same as before. Right? Even though we didn't call unsafe or unsync, IO app is going to do this for us. Okay, so it's all good. Okay, but as already mentioned, we're not going to use this one because we cannot use this one because we want to randomly pick an effect. Okay, so instead of this, what we're going to do is we're just going to throw everything out pretty much. I'm just going to say object main extends app. Okay, and then we're going to do Scala util random next int 3. Okay, so it's going to throw, it's going to give us the number 0, 1, and 2. Okay, so now we're just going to match, and we're going to say, so if it's a 0, then we're just going to print line in color, and in color is just going to be a tiny helper method down here. So we're just going to go and say private def in color. It's going to get the line, which is going to be a string. It's going to get the color, which is going to be a string, and string. It's going to be color plus line plus Scala console reset. Okay, so in color, and we're just going to do pretty much RGB. So we're going to say that the color for this is going to be Scala console red. Okay, and over here we're going to say running on Cats effect IO. Okay, and in this particular case, what is happening? Why do we have, there we go. That's what I want. Okay, so over here, what I'm going to do program.dsl Cats effect IO unsafe run sync. Okay, so pretty much the same as before. Okay, so now we're going to do case 1, and we're going to bring this guy down. We're going to say that this is going to be monix eval task. So it's going to be again red, green. Okay, we need a couple of imports. We need monix execution scheduler scheduler implicits global like this, and now we can construct another program.dsl for monix eval task. And because they wanted to make it fun for us, it's called a little bit differently. So it's not unsafe run sync, it's run sync unsafe. And it needs the duration.inf, which comes from Scala concurrent duration. Import Scala concurrent duration. Well, actually, let's do Scala concurrent like this. Okay, so I shall create more space like this. All right, let's see if I did everything correctly. I did. Okay, and then in any other case, like in every other case, we're going to duplicate this line over here. All right, so all the other cases is just going to be 2. Okay, so it's going to be running on zeal task, and I'm not gonna use blue because I want cyan because it's a little bit brighter. Okay, so we're gonna import zeal interrupt cats with a z, and we're gonna do zeal dot runtime default unsafe run sync. In fact, it also has unsafe run. I'm not really sure what the difference is. You can use both. Program DSL zeal task like this. All right, and in some of these cases, I believe like maybe in this one, no, I don't think. Yeah, we still need to specify. Okay, so now we have like these 3 versions, and we're just gonna run it now. Run, and in this case, it's gonna be monix. Okay, so we're gonna create, and we're gonna say, buy milk, and we're gonna say 220. Whoa, 227, 7, 4, 12, 11, like this. All right, there we go. Show all. Now, for monix, I have no idea why, but as soon as we quit, it's going to throw an exception. I'm not really sure why it does that, but this is the only one that does this. Like sometimes, as you can see, like right now, it didn't do it. If we run again, okay, somehow it's monix again. If we do show all, if we do quit, when I was preparing for this video, monix was the only one that was actually throwing an exception, and I have no idea why. Right now, it doesn't do this anymore. Super interesting. Okay, let's run it again. Okay, so now we have zeal. Same thing, create buy milk. 227 for 12, 12, like this. Show all. All works exactly the same as before. Let's run it again. And no, we already had monix. Let's run it again. Come on. Why is it bias for monix? Come on, let's do the 0. Cats.effect. There we go. All right, create buy milk. Buy milk. 227 for 12, 12. Show all. It's all good. Cool. All right, so the conversion is pretty much done. We're going to clean everything up and commit it in just a second. Just as a reminder, as of right now, we didn't throw out our implementation of cats and cats.io and all of these things. So you can play around with with our implementation. You can change it a little bit, or you can play around, with Zio, with Monix, just so that you understand, if you're using like ours, this whole Zio and Monix is not going to work, right? Because like even though things are called the same, they're not actually the same. In any case, let me go double check real quick if we need to clean something up. So we have the ref, it looks clean. We have the console, it looks clean. Random, it's fine. In-memory entity gateway, it's fine, fine. You can actually make it a private val, but again, like nobody cares. It's just for readability. Okay, statement. It's all good. It's all good. Yeah, it's all fine. It's all vals. Ref off and main. Right, and the program. Yeah, it's all clean. Dependencies, right? So we added this monadic 4, beta monadic 4, we added Zio, added monix, added cat's core, cat's effect. So yeah, it's all clean enough. Let's take a look at the build. I'm gonna leave these lines commented out for you guys. So if you want to like play around, if you want to like switch back and forth, that's good. That's good. That's good. And yeah, it's good. All right, so let's do GL. Okay, so let me actually, well, I can just do gcam, and this is going to be video 10. Video 10, but it's still going to be part 8, right? So it took me like 2 hours to record this, so I probably have, I'm pretty sure that I'm going to split it up. I mean, you already seen it, so it already has been split it up. So it's still going to be part 8, okay? So it's still like video 10, part 8. Let's do part 8, 8.2. How did we do this in the past? Because like the video 4, it had 2 parts. Okay, but we had only 1 commit. Okay, so let's do like part 8.2 and part 8. So let me grab something like this, rebase, and let's just reword this one, and let's just do 8.1 like this. Okay, so there we go, part 8.1 and part 8.2. All right, cool. All right, so I hope that you enjoyed this series so far. As I already mentioned, in the upcoming videos, we're going to build a proper database and a proper web server, and we're going to improve a ton of things. As of right now, we virtually have like no error handling. We still have some weird bugs. I haven't shown them to you, but there are like some bugs, hidden somewhere, because as a reminder, I have written this app like 2 years ago, and I wanted to keep it as simple as possible. So yeah, I'll see you in the next one. For now, it's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on GitHub or on Patreon, and thus watch my videos weeks or sometimes even months before everyone else, and most importantly, take care.